To break free from Earth's gravity, you need to ignite millions of pounds of thrust in a controlled explosion. The margin for error is zero. Every launch vehicle requires a specific, mathematically rigorous fuel mixture to achieve the exact thrust needed to reach orbit. In the 1950s, the U.S. space program was stalled until explosives expert Mary Sherman Morgan invented a completely new chemical composition called iodine, just to hit that precise thrust requirement for the Jupiton C rocket. Once you get up there, the environment is actively trying to kill you. In the vacuum of space, metals can spontaneously fuse together upon contact in a process called cold welding. And the atmosphere outside? It is filled with atomic oxygen that reacts with the materials on spacesuits, leaving returning astronauts smelling a distinct mixture of ozone, hot metal, and burnt steak. Because of these extreme conditions, cargo space on any mission is measured down to the millimeter. Every gram of weight is carefully calculated, strictly justified, and priced at thousands of dollars just to get it off the launch pad. But if you look at actual orbital manifests, this perfectly calculated frontier is littered with things that make absolutely no mathematical sense. Why would an environment defined by flawless engineering host vials of dirt from Yankee Stadium and Luke Skywalker's plastic lightsaber? Sometimes the strangest items strapped into a spacecraft are there to solve highly specific terrestrial problems. If a capsule veers off course during re-entry, the crew might land in some of the most desolate stretches of the planet. In 1965, 2 Soviet cosmonauts landed deep in the Ural Mountains and found themselves surrounded by wild wolves. After that close call, Russian survival kits routinely included actual firearms, packed tightly among the orbiting scientific equipment. Other oddities are launched purely for the data. In the 1960s, a Russian satellite carried vials of HeLa cells, an immortal line of cancer tissue. Researchers used the flight to observe biological behavior in zero gravity, discovering that the cells actually divided far more rapidly than they did on Earth. Today, researchers are pushing material science by looking backward. The LignoSat project, built by Kyoto University and the Japanese Aerospace Exploration Agency, is an experimental satellite constructed largely out of magnolia wood, launched to test timber's structural durability in a vacuum. When your primary goals are basic survival and extracting rare data, unconventional materials and weapons stop looking weird and start looking like necessity. But not everything in orbit was put there intentionally. Even when executing billion-dollar operations in zero gravity, humans are still capable of dropping things. During a 2006 spacewalk outside the Space Shuttle Discovery, astronaut Piers Sellers was tasked with smoothing protective liquid onto the shuttle's heat shield. His tool of choice was a standard kitchen spatula. Mid-repair, the spatula slipped from its tether and drifted away into the void. That simple slip created a massive problem. In low Earth orbit, that dropped kitchen utensil was instantly traveling at 17,000 miles per hour. At that speed, a piece of plastic and metal carries enough kinetic energy to punch a hole through a spacecraft. Military radar networks on the ground had to actively track the spatula as it circled the globe to ensure it didn't loop back around and collide with the space shuttle. The physics of orbit strips away the mundane nature of any object. Up there, a harmless tool for flipping burgers becomes a heavily monitored high-velocity kinetic threat. Then there is a third category of payload. Items that serve zero structural or scientific purpose, but manage to bypass the strict weight limitations purely through human sentiment. Shortly after landing on the moon in 1969, Buzz Aldrin asked for a few moments of radio silence from ground control. During that quiet window, he opened a small plastic package and secretly ingested communion bread and wine, turning the lunar module into a makeshift sanctuary. A couple of years later, Alan Shepard brought along a specially modified 6-iron. Standing in the dust of the Fra Mauro Formation, he took a one-handed swing and turned the lunar surface into a low-gravity driving range. Even our most recent missions carry these traditions. The crew of the Artemis II flight packed a plush toy moon mascot named Rise. Official protocol stated the toy should be left inside the capsule at the end of the mission, but astronaut Reed Wiseman couldn't leave it behind, secretly stashing it inside his dry bag to bring it all the way home. These artifacts prove that astronauts cannot operate solely as biological machines. To survive the psychological weight of the void, they require physical tethers to human rituals, sentiment, and humor. Mathematically, spending thousands of dollars in rocket fuel to transport human ashes, religious relics, or plush toys into orbit is a complete waste of resources. But these irrational objects solve a problem that aerospace engineering cannot fix: the profound, overwhelming isolation of leaving your home planet. Packing these items ensures that our orbital footprint reflects our actual civilization. We bring our religions, our sports, our clumsiness, and our inside jokes into the vacuum right alongside our thermodynamic achievements. Future archaeologists digging through our orbital record will encounter a messy, bizarre reflection of human culture. Our titanium thrusters and spent fuel stages will be found resting right alongside our sports, our rituals, and our sense of humor.